morning, ladies and gentlemen. I'm Rosemary Bartlett with the Pacific Northwest National Laboratory, and I'd like to welcome you to today's webcast, Standard 90.1-2004, an overview of the lighting and power requirements, brought to you by the U.S. Department of Energy's Building Energy Codes program. Our speaker today is Eric Richman, a senior research engineer at Pacific Northwest National Laboratory. Eric is the current chair of the 90.1 Lighting Subcommittee. Eric, you may begin.
Hello and welcome. I'd like to start with a little bit of a basis for the energy requirements so everyone understands why we have these requirements and where they came from. As some of you may remember, the Energy Conservation and Production Act, which has been amended by EPAC a couple of different times, has a requirement that states adopt a commercial energy code. And this, of course, is the basis for why states have adopted and continue to adopt an energy code to meet this requirement. Part of the Energy Policy Act requirements are that DOE determine an efficiency or stringency level that must be met by the codes that are adopted. And of course, this, if this ever changes, this forces a state to go back and reevaluate what they've adopted and consider adopting a more stringent code. And this goes on continuously among the different states, which is why you'll see different versions. And of course, there are different versions of the codes, and states do adopt them. There are several that are available, and some states you'll see will adopt a nationally available code or standard, of which ASHRAE IESNA 90.1 is one of. Some states will develop their own codes, and these can be based on a national code or their own development process. And some states, regardless of the requirements, still have no code. They may be in the adoption process or in the development process. To look at graphically what this kind of means, you can see that the various states adopt various different codes. There's quite a variety out there. There is the newer 2006 IECC, which references the ASHRAE 90.1-2004 that we're talking about today. Utah and Pennsylvania specifically have adopted that. But the point here is that you will see a lot of different codes among different states. And if you do work in more than one state, you'll have to deal with more than one code. A lot of the requirements in the ASHRAE 2004 standard are similar in a lot of these other codes. So a lot of what we're going to talk about today will be applicable, but you will find different requirements, so you'll need to check with each state to make sure you're complying with the right code requirements. So let's go on to a little bit of basics on the 90.1-2004. It is a jointly sponsored standard by ASHRAE and IESNA. It has been for many years. 2004 is the current version of the ASHRAE 90.1 standard. The 2007 version will be out soon. Many states have an older version of 90.1 in place, as we discussed before, 2001 99 version, and some even still have the older 1989 version, but that's fast going away. Some states have adopted a state-specific code developed by themselves or taken from other nationally available codes, and the IECC, which is another nationally available code. Both of these are based on, a lot of these are based on requirements in the 90.1 code. IECC itself does reference versions of the 90.1 energy code as a compliance option. As we mentioned, the IECC 2006 references the ASHRAE 90.1-2004 version that we're talking about today. The 2004 version is also the Commercial Building Code reference in NFPA 5000, which is being adopted by some states. And one other note, as you may be aware, this current 2004 version of the standard did have a major change in the lighting power density requirements when it came out that makes it approximately, on a building type across the country basis, an average of about 25% more stringent than previous versions of the standard, which is why it's gotten a lot of interest and why we want to discuss this a little bit more. So we're going to look at the lighting and power requirements. The power requirements are fairly simple and straightforward, so let's dispense with those first. The major requirement for the power section is on voltage drop. And for your feeder conductors that run between your service entrance and the branch circuit, there's a requirement that they have a maximum 2% voltage drop. For the branch circuits that then go from the final circuit breaker to the outlet or load, there's a 3% maximum voltage drop allowance. And these requirements are to try and eliminate as much line loss as possible within the building. Another building power requirement, the only other one really worth mentioning is a requirement for document submittals. And this is in place so that owners can get the kind of information they need to either modify or deal with their electrical system and understand how it works. One of the requirements are for record drawings of the actual installation. This would include single line diagrams of the distribution system and floor plans that show the location of distribution equipment and areas served by the equipment. Another requirement are for manuals. These must be submitted that include data on the equipment, nameplate ratings, etc. for the electrical distribution equipment. It must include operation and maintenance manuals for equipment where applicable. There needs to be some information on qualified servicing agencies, and there needs to be some sort of complete narrative and schematic of the system as it's normally intended to operate so that maintenance personnel and operations personnel can make the best use of the system as it's designed and installed. That covers it for the power requirements. We're going to spend the rest of our time talking about the lighting requirements in the 90.1 standard. First, let's look at the scope, what the application of the standard is to lighting. It does apply to both new construction and additions, and it applies to all commercial types of buildings. That includes residential buildings that are 4 or more stories above grade. If you have a residential building, for example, an apartment complex, that's only 3 stories or less, it would not have to comply with the commercial version of the standard. In that case, you would look for a residential energy standard for compliance with that building. But if it's over 4 stories, then you must go to the commercial applicable code. There are some exceptions to all the requirements in the lighting section. One is for lighting in dwelling units. Let's go back to that apartment complex again. If you have a 4-story apartment complex that must meet the commercial code, the lighting within the actual apartments would be exempted. That would be the living spaces. However, any of the lighting in common spaces, such as a lobby or hallways or a community laundry room, etc., those spaces would have to comply with the energy code, just not the individual dwelling units themselves. Another exemption is for emergency lighting that is normally off. Your typical battery-powered emergency lighting, of course, is exempted from compliance. If you have any life, health, or safety statutes that apply to the building, that specific lighting that's required by that statute would be exempted as well. And if you have a building that perhaps is on a state or national historic register, the lighting in that building and around it would also be exempted. There are lots of historic registers. Typically this means a state or national one, but if you have a local one, you may want to talk to your local building official and see if that would apply for an exemption as well. Alterations and renovations are also part of the lighting scope. Essentially, you treat that as a new construction, in that if you change anything, it must comply with the code. And there are some exemptions to that, of course. Let's look at the basic lighting requirements, how they're laid out. There are 3 sections. The first one are mandatory requirements, and there are mandatory requirements for both interior and exterior. They generally deal with control of the lighting, switching, how switches are laid out for control of the lighting, and there are some efficiency requirements as well. The major portion of the requirements are prescriptive on interior lighting power limits, and the basic requirement is that the total connected power in the building must be less than or equal to the total allowed power that you are given to use within the building that is prescribed within the standard. There are some exemptions to this requirement, exemptions to the total connected power you have to include. And in terms of determining your lighting power allowance, you have 2 methods, a whole building method and a space-by-space method, which we will discuss in detail. The space-by-space method does have some additional allowances that are very important for design, and we'll discuss those as well. A third part of compliance is for exterior lighting power limits. Of course, there are some control requirements here as well as lighting power density requirements. These are split into tradable and non-tradable spaces, which is a little bit different than the interior requirements, but we'll go over those in some detail as well. So let's move on to a few words first about alterations and renovations. As we mentioned, those are included in the scope of the standard as well. And if you are renovating a building, the requirement is essentially that if you replace it, it has to meet the energy code, and this applies to luminaires as well as control requirements. If you are not going to modify or replace the lighting whether it's luminaires or controls, then you don't have to show compliance. If you are, there is one exception, and it's on a space-by-space basis that says if you're replacing less than 50% of the luminaires, you don't have to comply. Now, an example of this might be if you're going to replace, say, only 10% of the luminaires in a lobby, then you would not have to show compliance for that lobby space. But the office spaces in that building, if you're replacing, say, 90% of the luminaires in all those spaces, those areas would have to comply with the code. That's the way the 50% exception applies. It's on a space-by-space basis. So let's move on to the mandatory requirements. Looking at individual space control, the requirement is that for each room or space enclosed by sitting height partitions, you must have at least one control. And there are limits to how much lighting each of those can control. In spaces that are greater than 10,000 square feet, each control must serve only 2,500 square feet, again to provide some flexibility. If you have larger spaces greater than 10,000 square feet total, each control can serve 10,000 square feet maximum. These controls must be readily accessible to the occupants. The idea, of course, is to allow the occupants a way to turn off lighting if it's not needed. There is an allowance or an exemption, or an allowance actually, for remote location of these switches to accommodate areas where there is a safety or security issue. For example, if you have a area where there are safety issues and the lights need to remain on for certain periods of the time, and you don't want occupants to be able to control them without some kind of security control, that switch can be allowed to be remotely located. But you must have a way with this remote location to see what lighting is controlled or have it labeled and be able to tell whether the switch is on or off. Some more mandatory requirements. There are some specific spaces that have their own specific space control. One is hotel, motel, guest room lighting, where the requirement is that all of the permanently installed lighting and switch receptacles must have a control at the exit of the room. The idea being here that if you have a light on in the back of the room and the occupant is leaving, they must have a way of turning those lights off without having to walk back into the room to turn the lights off. This is intended to encourage occupants of these spaces to be able to turn off the lights without any extra effort. Another requirement is for specific spaces that must have an occupancy sensor requirement. One of these are classrooms. There are some exceptions to this. If you have a shop or lab classroom, there is potentially a safety issue with an occupancy sensor, so it's not required there. K through 12 classrooms are considered to be occupied most of the time, and so there's less energy savings, and those are exempted at this point. But any other classroom is required to have an occupancy sensor. Conference and meeting rooms, no matter what kind of building type it is, must have an occupancy sensor. And any employee lunch and break rooms, again, in any building type, must have an occupancy sensor. These requirements, of course, are there to capture any wasted light when users don't turn them off themselves. There are some additional individual space control for specific applications. In these places, there must be control of this lighting separate from the overhead lighting. Display and accent lighting must be separately controlled. If you have any lights within cases, that must be separately controlled from the overhead lighting. If you have task lighting, desk lamps, etc., those have to have their own control. Non-visual lighting, such as warming lamps or plant growth lamps, those have to be separately switched. And if you have any demonstration lighting that's for sale, for example, in a retail establishment, the actual lighting that is for sale must be separately switched from overhead general illumination. Some more mandatory requirements. One of the major requirements is for automatic shutoff. And the requirement is that any building larger than 5,000 square feet must have automatic lighting shutoff that will control all the lights in the building. There is a requirement that you have to have override capability, which will last for not more than 4 hours. The idea being, of course, to give an occupant the capability of coming in after hours and turning on lights in their space when needed without turning on all the lights in the entire space. There are some exceptions to this automatic shutoff requirement. If you have lighting that is intended for 24-hour operation, of course, it makes no sense to have automatic shutoff, so you're exempted. A couple of other ones that speak to safety or security issues. If you have patient care spaces, for example, a patient room in a hospital would not have to have an automatic shut-off because there might be a security issue there. And a generic item, any other areas with safety or security concerns, similar to patient care spaces, can be exempted as well. Now, this is a generic requirement. It isn't very specific, so you will need to make your case with the building official when you have one of these to identify what the safety or security need is and document that such that the building official will be able to agree with that. And again, the intent here is to eliminate after-hours lighting waste where it makes sense and is practical. So how do you comply with this automatic shutoff? There are three basic ways to comply with this, and you can mix or match these. The first one is on a scheduled basis, some kind of an automatic time switch. This can be part of an energy management system. It can be simple switching. It has to be something that's programmed so you can have time of day control, and there are limits in terms of the area of control. You can control less than 25,000 square feet and not more than one floor for each control node. You can't control any more than that. Again, this is to provide some flexibility, so you can turn off parts of the building and not others when the schedules dictate that makes sense. A second way to comply with this requirement is with an occupancy sensor. Any occupancy sensor that turns off the lights within 30 minutes of the occupant leaving the space is allowed. And you can, again, mix and match this with the first compliance option. So you could have a scheduled basis for some areas of the building, and then for others where you want perhaps more individual control, you can have occupancy sensors in those areas. A third compliance option, which is somewhat of a catch-all, is for a signal from any other control or alarm that indicates the area is unoccupied. This is in there because there are some emerging technologies, either computer workstation-based or other alarm-based, that will provide the same occupancy signal, and these can be used as well to show compliance. Of course, these requirements are for automatic controls. Manual switches do not comply with this requirement. And one other note for those of you familiar with earlier versions of the ASHRAE code and other national codes, there has been some language when this was originally enacted in the codes that said occupant intervention was one of the options, and this has been interpreted as a manual control. This has always been from the very beginning somewhat of a typo, and it was never meant to be put in the standard. It's been corrected, of course, in later versions of the national standards, such that it isn't in there anymore. The point being that you cannot have manual control and comply with this automatic shutoff requirement. So one other note about application of this requirement: the requirement states it has to apply to any building greater than 5,000 square feet. The intent, of course, is if your building is of a certain size and you can effect a schedule, it makes sense to turn the lights off automatically. Now, let's take a couple of examples. One would be a strip mall. Say it's a 10,000 square foot strip mall. According to the code, it would require this automatic control system. But each individual business in a strip mall may be 2,000 square feet, for example. In this case, because the business hours of the strip mall might be different for each individual tenant, it isn't often practical to have a whole building controller for this particular building. So the application here is to each individual business. So since each business is less than 5,000 square feet, there would not be a requirement for whole building or business automatic shutoff. Another example might be a multi-tenant office where different floors or wings of the office are occupied by different tenants. In this case, a whole building controller would make sense in that you can schedule each wing or each floor of the building separately, and you could match that with each individual tenant. And these will tend to be larger buildings where it is cost-effective to put in a whole building controller. If you have other odd cases, you'll simply need to make your case with a building official and see what kind of compliance makes sense in that case. Let's look at a few more mandatory requirements, these having to do with exterior lighting control. There is a control for lights to be on a photocell if there is dawn-to-dusk operation of that lighting. Or you can have a 7-day programmable system with astronomic correction and 4-hour battery backup. This would comply as well. There are exceptions to this requirement. If you have covered vehicle entrances, you don't have to have this automatic control because it doesn't often make sense. And if you have exits from a building or parking structure where there is an issue with eye adaptation for safety or security, these can be exempted as well. And of course, in this case, these can be somewhat subjective. You'll need to make your case with the building official and document that there's actually a need there for them to agree with it. And again, the intent here is to eliminate any exterior lighting that's on during the day when it's not needed. A few other mandatory requirements. One having to do with somewhat older technology, but some of it still exists today, so it's still in the standard. Having to do with tandem wiring. The issue here is to eliminate the use of magnetic ballast driving single lamps. Most magnetic ballasts are designed to drive one or two lamps. If they're driving one lamp, they still have a lot of line or operational losses, and it would be much more efficient if they're driving two lamps. So if you have an application with 3 lamp fixtures, the code wants to make sure that you're taking the odd lamps and driving both of them off of a single ballast, which is the tandem wiring requirement. Now, there are exemptions to this. If your fixtures are spaced far apart, more than 10 feet, you aren't required to comply with this. But if they are within 10 feet, you do need to wire them such that you do not have any magnetic ballast driving single lamps. Of course, if you're using high-frequency electronic ballast, this requirement doesn't apply. It's only for the magnetic products. Another mandatory requirement having to do with exit signs. The limit in the current 2000 version is 5 watts per face for every exit sign. And with newer technology, this shouldn't be any problem to meet. There are commonly lots of exit signs that meet this requirement. That covers the mandatory requirements. Let's go on to the prescriptive requirements, the major one being the compliance with the interior lighting power limits. This prescriptive requirement has 2 ways to comply, a whole building or space-by-space method. And the requirement is essentially you compare your actual installed power, the wattage you're going to use for lights in the building, with a lighting power allowance, again, the lighting power density limit that comes from the standard itself. And as we mentioned, there are some additional lighting power allowances and some exemptions, and you'll want to consider those carefully and make use of those because these are important for lighting design within a building. A few words about a performance option, the energy cost budget. This is an option for compliance with the energy code that does not require you to meet certain prescriptive requirements. It is a whole building energy use modeling system where you compare a prescriptively complying building within an energy model to the building you're going to build with all the controls and lighting, wattage, et cetera, that you're going to put in the building. If your energy use is at least as low as the prescriptively compliant building in the model, then you comply with the energy code. This method can provide a lot more flexibility if you have a complicated building design, but it does require a lot more input. It is only for whole building energy. You cannot do it separately for lighting or mechanical or envelope. It has to be the entire building as one unit. So it is a lot more involved. If you have a complicated design or complicated building, this might be the option for you. But if you have more simple requirements, then you may find it's not cost effective to go there. Let's look at how you determine the installed power, again, on the prescriptive path. What you are going to do is calculate your installed lighting wattage for the entire building space. That's the wattage you are going to apply for compliance. And this must include all permanent and portable interior lighting that is part of the design, whether it's for general, ambient, or task illumination. If it's part of the design, it has to be included. Now, if you provide a design for a building that does not have any task lighting, for example, the lighting requirements are going to be met with the overhead lighting, and the tenant, when they occupy the space later on, bring in their own task lighting for whatever reason. If those were not part of the original design, they don't have to be calculated as part of the compliance. However, if you design with a task ambient system where you have some overhead lighting and some task lighting, that's part of the original design, and that task lighting must be included. There is an exception to this. If you have 2 or more mutually exclusive lighting systems where only one can be on at a time, then it's only the wattage of the highest wattage system that must be calculated. You don't have to use both. So let's look at how you determine this installed wattage. There are some calculation rules you have to go by. The first one being for standard incandescent downlight type applications. It is the labeled wattage of the luminaire that you must use for compliance. So, for example, if you're going to propose to put a 60-watt lamp in a luminaire that's labeled for up to 150 watts, you have to use that 150 watt rating for your compliance. So you may find that you'll want to look around for a fixture that has a wattage label closer to what you're actually going to put in, so you don't get dinged for something you're actually not going to use. If you have any luminaires that are driven by ballast, fluorescent, HIDs, etc., it's the wattage of the lamp ballast combination, not just the nominal lamp wattage that you have to use. It's very important. You can't use nominal values. It has to be lamp and ballast combinations. If you have line voltage track, the requirement is the actual wattage of the heads you're going to put on the track, or a minimum of 30 watts per foot. And that's a minimum of 30 watts per foot. So you calculate the heads you've got, calculate 30 watts per foot. Whichever is higher, that's the value you have to use for line voltage track. If you have low voltage track, it's just the transformer wattage rating that's applied to that piece of track that you have to use. Anything else besides those, it's the specified manufacturer's rating on the equipment that you would need to use. Again, these are just the rules you apply for each of the different luminaires in calculating the wattage you're going to put into your space. As we mentioned before, there are a bunch of exemptions. This is lighting that you do not have to include when you're calculating the wattage you're going to put in the building for compliance. You don't have to add these up. I won't go through each one of these, but there are some that note some that should be noted specifically. The first one, theatrical stage, film and video production. This applies to the lighting used for the production of that event, not for overhead lighting. So, for example, in a theater, it wouldn't be any of the working lights or the back of house lights, auditorium lights, etc. Those are still fair game for compliance. But any of the specific lighting used for the production, whether it's theatrical stage, film, or video, those would be exempted. Any lighting that's used during a medical or dental procedure that's in addition to the overhead lighting would be exempted. So, for example, the articulated light in a dentist's office that's moved around for better task lighting would be exempted, but the overhead lighting on the ceiling that's for general purposes would not be exempted. The third one, displays and accent lighting in museums and monuments. Again, it's not the overhead lighting for general illumination. It's just the lighting that's there specifically to highlight exhibits and displays. You have to keep those two separately. Another one of note, in retail display windows, it's exempted only when the display window is enclosed by ceiling height partitions. So if you have a window display, but that window area is open to the rest of the retail sales floor, you cannot exempt that lighting, only when it's a separately enclosed retail display. The next one down, for use in areas specifically designed for the visually impaired. If the space was designed specifically to accommodate visually impaired people, and that's its only purpose, then the lighting would be exempted. But a space that may have visually impaired people visiting it is not enough of a reason to exempt the lighting. It has to be specifically designed for that use. Another one, integral part of advertising or directional signage. This speaks to the idea that if it's part of the equipment, it's exempted. So if you have lighting within a sign that's purchased to put on the building, that lighting is exempted. Another one, similar to the theatrical exemption, for television broadcasting of sporting activities. Again, it's not the general lighting of the sporting arena or surrounding areas. It's only for specific lighting that is used for the television broadcasting. That lighting itself could be exempted, but not the general lighting. Of course, casino gaming areas, and this again is the gaming area itself. Back of house areas, office areas, hallways, etc., would not apply, just the casino gaming areas. And one note, in the later version in 2001, there will be another. In 2007, there will be another exemption for task lights that have an occupancy sensor control. If the task light incorporates that control, it can be exempted as well, even if it's part of the basic design of the space. That covers it for exemptions. Let's go on to how you calculate your interior lighting power allowance from the standard. The first thing you do is to choose an appropriate lighting power density that you'll find in the standard. And there are two ways to do that, of course, as mentioned. A whole building path. This is the easiest path, but it does provide less flexibility. In this case, you pick one value for the entire building and apply that to the square footage. You don't have any flexibility of each different space type, even if the lighting requirements might be different. The space-by-space path requires more effort on your part. You have to calculate the square footage and divide out the different spaces in the building. but you potentially get a higher allowance because every individual space type has a different lighting power density. Once you've chosen these values, then multiply them by the square footage. If it's whole building, you multiply by the total square footage of the entire building. If it's space by space, you multiply each individual LPD by each individual space type and sum up those values. Now, the point I want to make is that if you're using the space-by-space method, you may get additional allowance, but it depends on the mix of the spaces within your building, and we'll talk about that a little bit later on. Wanted to show you what some of the lighting power density values look like. This is a portion of the table. The table includes approximately 120 different space type LPDs. This is just one part of that table. One thing to note here is you'll see there are a lot of what are called common space types. These are space types you find in lots of buildings, and they're similarly lighted, and so they have 1 watts per square foot value, no matter what kind of building type it's in. The rest of the table you'll see are for individual building types with space types that typically are found in just those building types. And if you're using the space-by-space method, you'll want to look through this table pretty carefully to see what your choices are and make sure you pick the most appropriate value. Let's look at the whole building LPDs. If you go with the whole building option, this is the entire table that you'll see in the 2004 standard. And again, if you're, for example, have an office building, you want to do the simple method, you pick the office lighting power density of 1 watt per square foot, you're going to apply that to the entire square footage for the entire office. In this method, you don't look at individual space types. So I'd like to spend a little bit of time talking about where these lighting power density values came from. Before the most recent version, these numbers were somewhat just chosen by committee based on experience, based on consensus of the committee, what they had seen before, what they thought was reasonable. But as of the 1999 version of the standard and moving on to the 2001 and the current 2004 version of the standard, a rigorous modeling process was put together to come up with more reasonable values, more applicable to all space types. And this is a modeling process where you have 4 basic inputs to the model. The first one are current lighting product performance data, and these are on fixtures that are efficient, but not necessarily high-end fixtures, not low-end, but efficient, commonly available luminaires on the market today. We add into that mix current lamp ballast efficacy values, and there's some recent light loss factor data that's also incorporated into the model, so we can characterize the entire space that the luminaires are being put in, each of the different various space types. The latest IES recommended light levels for these space types and casts and applications is also included in each of the models. And as a final item, professional consensus to account for differences in design, perhaps a space type where the IES recommended light levels don't quite match. Again, consensus of lighting professionals to make sure that the models accurately represent what's really going on in that space type. All of these 4 elements are combined into the space type models, and using essentially a lumen method calculation, the model comes up with a lighting power density in watts per square foot for each space type. And those are the numbers you'll see in the space by space table in the standard. So what about whole building LPDs? Where do those come from? Those use the same modeling basis. What happens is the standard takes those individual models, 120 of them, and applies them to typical whole buildings to come up with a typical whole building value. The question is, where did the space type data come from for these whole building models? The source of that is the McGraw-Hill Dodge construction data plan sets. These were accessed. The current database includes 246 buildings for 31 different space types. Of each of those 246 sets of building plans, detailed takeoffs were done for each space type within the building. And once these space type values were taken out of the buildings, these were applied to the lighting power densities for each of the space types. And what you get out of that is a whole building value for each of those 246 buildings. And you then average those across the 31 building types, and you come up with a whole building lighting power density. This is where I mentioned before that if you have an unusual building, you might want to consider the space-by-space method, because this process comes up with a typical whole building LPD. So again, if your building is unusual, you may find more wattage if you go to the space-by-space method. So if you're interested in how this process works, want to look at more detail about the space-by-space development or the whole building development, there is a spot on the IESNA website where you can go and actually look at the modeling process. You can march your way down through the entire process from the luminaire choices all the way down to the IES light level recommendations, the choice of luminaires, etc. You can also do what-ifs at this site. If you sign in, you can make changes to a version of it and see what would happen to the lighting power density value if you change the models. So if you're interested, go out to that website and take a look. All the details are out there. We had mentioned before about additional lighting power allowances to provide flexibility in lighting design to meet the prescriptive requirements. So we want to talk about that a little bit. There are additional power allowances. They are use it or lose it allowances. In other words, you can apply them to specific applications, but you cannot use them for any other generic space. So if you have an allowance that's more than your specific application, you cannot use what's left over anywhere else. They are truly use it or lose it. They also should be separately switched from the general overhead lighting because they are a special case. So let's look in detail at what those are. There are 3 additional power allowances. The first one is for decorative luminaires in addition to general lighting. And a classic example here might be a lobby that has some decorative chandeliers or decorative wall sconces. If these are separate from the general illumination in the space and they're only for decorative purposes, you can get an allowance of an additional 1 watt per square foot for that space. But again, these have to be separate from the overhead lighting, the general lighting in the space. A second allowance is for luminaires that have been designed as part of a space to reduce computer screen glare. And there are requirements or recommendations in IES for this kind of design. If those are met, then you can get an additional 0.35 watts per square foot for that space. But again, there are design requirements that have to be met to claim this allowance, and you'll want to look at those in the standard. A third allowance, which gets the most interest because it's very much applied and very much needed for retail lighting design, are retail display allowances. And there are 2 of them. The first one is an additional 1.6 watt per square foot for specific display of general merchandise. And I say general merchandise because the second one lists some specific ones. But the point here I want to make is that it's 1.6 watts per square foot of specific display. This is not 1.6 watts times the sales area or 1.6 watts times the entire building area. It's 1.6 watts times the actual specific display. So, for example, if you have a retail shoe store and you have a wall that's covered with shoes, the area of that wall that's covered with shoes would be applicable to the 1.6 watts per square foot. If you had a group of mannequins or a shelf, it would be the area of the group of mannequins or the area of the shelf that you would apply the 1.6 watts per square foot to. The second allowance, 3.9 watts per square foot, is again for the specific display, but it is for specific merchandise. And it actually says valuable merchandise such as jewelry, fine apparel and accessories, china and silver, art, and similar items. And it adds where detailed display and examination of merchandise are important. So those are the criteria that must be met. If you have jewelry, for example, that doesn't require any detailed display or examination of merchandise, that wouldn't apply to this 3.9 watts per square foot. There may be other types of merchandise. For example, it says fine apparel and accessories. Maybe there are some other accessories or similar items that you feel need that additional highlighting. If that's the case, you would want to make your claim to the building official stating why it requires that kind of examination and ensure that they're going to accept that. So that covers the prescriptive requirements for the interior lighting. Let's go on to exterior lighting power. One of the first requirements for exterior lighting is with the building grounds, and the requirement is that any luminaires that have light sources over 100 watts, the light source itself has to have a lamp efficacy of at least 60 lumens per watt. Now what this will do will be to eliminate any incandescent sources and some inefficient fluorescent sources, but most efficient fluorescent and HID sources will apply here. But again, remember, this is only for sources above 100 watts. So if you have small over-door lights that are less than 100 watts, you still will be able to use just about any source you want. The other major requirement for exterior lighting power is the prescription of wattage limits, similar to interior lighting, but with a few differences, which we will explain. The exterior applications here are divided into two categories. This is unlike the interior. All the space types in interior were treated essentially the same, but in exterior there are two different categories, tradable and non-tradable. Tradable surfaces are those where the allowed wattage that you come up for the entire exterior application can be traded among them. You can, once you get your total wattage allowance, you can use more in the parking lot and less in a canopy, or vice versa. You can use it wherever you want. The non-tradable surfaces are specific applications. Again, it's a use it or lose it allowance. The wattage for these must be used in the specific application and cannot be traded either among themselves or traded to the tradable applications. They must be used in that case, or the remaining part cannot be used anywhere else. So let's look at how this works. Again, it's the total interior lighting power allowance, which is the sum of all the individual lighting power densities throughout your exterior application. Another difference between the interior lighting is that you do get to add an unrestricted allowance of 5% of that sum. And this can be used anywhere you want it. If, for example, the code doesn't cover an application that you need lighting for, this 5% allowance will help you with that. Trade-offs, of course, as we mentioned, are only allowed among the tradable surface applications, but you can use this 5% anywhere you would like. Some exemptions, of course, apply to the exterior lighting power, and we will go over those as well. But first, let's look at the tables and talk a little bit about the different kinds of surfaces. The first group, as I mentioned, are tradable surfaces, and again, these have wattage that you can trade among themselves anywhere you want to use it. A major item, of course, parking lots and drives. Any of those areas get a 0.15 watt per square foot allowance. You have several building grounds categories, walkways less than 10 foot wide, and you'll notice that this is on a linear footage basis, 1 watt per linear foot, not per square foot. If you have walkways greater than 10 foot wide, or plaza areas, special feature areas, these are on a watts per square foot basis at 0.2. If you have stairways, these are external stairways, not internal stairways, you have an allowance of 1 watt per square foot for those. Some more tradable surfaces. There are a couple for building entrances and exits. You have a main entry door. You're allowed 30 watts. And again, this is per linear foot of door width, not square footage. It's linear foot of door width. And for any other doors that are not main entrance doors, there's a slightly lower allowance of 20 watts per linear foot. These other doors would be, for example, an employee entrance door or a back door, if you will, anything that's not considered the main entrance into the building. There is a category for canopies and overhangs, and this applies whether they're freestanding or attached. You get an allowance, again, per square foot for any square footage you have as a canopy or overhang. For outdoor sales areas, there are two categories of allowance. The first is for the general open area, and let's use a car lot as an example, probably the most common. The entire area where you have merchandise is allowed a watts per square foot value of 0.5. However, there's also an understanding that the frontage area of outdoor sales is important for sales purposes. So there is a street frontage allowance for vehicle sales lots in addition to the open area, and that again is on a linear foot basis, 20 watts per linear foot for the frontage of the sales area. That covers it for tradable surfaces. Now let's look at those non-tradable surfaces, and again, these are specific allowances that cannot be traded among other applications, either themselves or other tradable surfaces. The first one, building facades, and there are two ways to comply with this you'll see in the table. One is on a watts per square foot basis of the illuminated wall or surface area. And if you can't really calculate what that is or prefer not to, you can also use a linear footage basis, 5 watts per linear foot for the length of each wall or surface that you're going to illuminate. You can choose which one of these methods you use, but you can't, of course, apply both. If you have An automated teller machine or a night depository, you get a flat 270 watts per location. If you have, for example, 2 teller machines right next to each other, you would get 270 watts for the first one, 90 watts for the additional one. As a different example of that, if you have a teller machine on one side of your building and another teller machine on another side of the building, those are considered separate applications. Each one of those would get 270 watts. And again, if there are ones next to it, 90 watts for each additional location. There's also a limit for entrances and gatehouse inspection stations of 1.2 watts to 1.25 watts per square foot of uncovered area. The note here is that if it's a covered area, that's going to be included in the canopy and overhang section. It wouldn't be in this section. This is only for an uncovered area. Another non-tradable surface for loading areas, for law enforcement, ambulance, etc., 0.5 watts per square foot. And again, this is for uncovered area. So if you have a canopy over your ambulance area, for example, next to a hospital, that will be covered in the canopy and overhang section, not in this section. And there's also an allowance for drive-up windows at fast food restaurants. Again, a flat 400 watts per drive-through. Again, if you don't use all 400 watts there, you can't use it anywhere else. And a final item, parking near a 24-hour retail entrance, you get a flat 800 watts for that main entry. Again, if you don't use it all there, you cannot use it anywhere else. We mentioned there were some exemptions to the exterior lighting power. This is the list, and again, these are exemptions such that when you're calculating the lighting power of your exterior design, your exterior application, these do not have to be counted. And again, there's a lot of them here. We don't need to go through all of them. Some of them you'll see are similar to the interior lighting exemptions, and they apply here as well. A few to note, lighting for athletic playing areas. Again, this is the lighting for the playing area itself. Any auxiliary spaces would not be exempted. Those would have to comply with the exterior lighting requirements. So, for example, a parking lot next to an athletic playing area is fair game for the code or for compliance with the code, but the athletic playing area itself would be exempted. Lighting for industrial production, material handling, etc. areas, that is exempted, but again, it's only for the industrial production area. For example, the parking lot next door would not be exempted. It would just be the production area itself. Theme elements and theme amusement parks, the same kind of application. If it's the theme element, the sparkly lighting part, that's exempted. But the back of house areas, common areas, parking lot areas, etc., those would not be exempted. It's just the theme element parts. And again, lighting used to highlight features of public monuments would be exempted. Again, the parking lot is not part of the historic monument, so it would not be exempted, but just the monument itself would be. That covers the exterior lighting requirements. Of course, if you want some more information or want to get a copy of the standard or the user's manual, and there is a user's manual for the standard 90.1/2004, which does provide additional examples, more information. If you have a question about application, the user's manual is usually where to get that information. That, and as well as some detailed training opportunities, are available from the ASHRAE website itself, ashrae.org. You can also get a copy of the standard itself from IES at IESNA.org because they are a co-sponsoring agency. If you have questions on the standard itself or need some information on some other compliance tools, you can also go to the energycodes.gov website, and there's a lot of information out there on the code as well. Thank you much.
Well, thank you very much for an informative webcast, Eric, and thanks to all of you. The U.S. Department of Energy Building Energy Codes program certainly appreciates your attendance today. Before we begin answering the questions that have come in, I'd like to put up the link where you can provide us with your AIA information or print a certificate of completion.